by a convex lens. Part 1. Objectives. To study the nature of image formed due to a convex lens, to see its practical applications. For the sake of simplicity in studying about the images formed by a convex lens, we will use a linear object like a candle kept perpendicular to the principal axis of the lens. Consider the ray emitted from the top S of the candle traveling parallel to the principal axis of the lens. It reaches the lens at point P and then deviates to pass through the focal point F of the lens. Another ray from the top of the candle passing through the optical center O of the lens goes undeviated to intersect the previous refracted ray at point S'. An image is formed at this point where the two refracted rays intersect each other. Hence, we have seen how an image is formed in a convex lens. The image of an object changes depending on the distance of the object from the lens. Firstly, let the object be positioned at an infinite distance. The rays coming from the object will be parallel to each other. These parallel incident rays can be of two types. These rays may be parallel to the principal axis of the lens, or they may not be parallel to the principal axis of the lens. In the first case, the parallel incident rays, after passing through the lens, get converged to intersect at the principal focus F on the other side of the lens. Due to this, a real, inverted, and highly diminished image is formed at the focal point. This type of image formation can be seen when we hold a magnifying lens near a paper and parallel rays from the sun undergo refraction through the lens. They converge at the principal focus on the other side of the lens. And when the intense radiation of the sun are focused onto the paper kept under the lens, it gets burnt. In the second case, parallel incident rays from the object do not converge exactly at the focal point, but at some point S' in the focal plane on the other side of the lens. Due to this, a real, inverted, and diminished image is formed at point S'. This type of image formation is used in an astronomical telescope, where parallel rays from a distant object, after passing through a convex objective lens, get converged on its focal plane. Secondly, if the object is positioned somewhere between infinity and twice the principal focus to F1, then the incident rays from the top S of the object on passing through the lens converge at a point S' between F2 and 2F2 on the other side of the lens. Here, the image is real, inverted, and diminished. This type of image formation is used in a camera where rays coming from an object which is not very far pass through the convex camera lens and converge at a point between F and 2F on the other side of the lens. They then pass on to the photographic film. Thus, the image gets captured onto the film. Thus, we have studied how an object kept at different positions with respect to a convex lens produces different types of images. We have also understood how these image formations can be applied to practical purposes using various optical instruments like burning glass, astronomical telescope, camera.